Hello YouTube and welcome to What the Math. In today's video we're continuing chapter 13, coordinate geometry, and we're going to be doing sub-chapters C and D, gradients and also parallel and perpendicular lines. These are two related concepts, starting with the gradient. So what is the gradient? And here are four different lines that represent four different gradients. Gradient is also known as the slope. This is something you may remember from grade 9 algebra. And basically, this is what we're going to be doing, slope or gradient. So what is it, how do you find it, and why do we need it? Well, this is what it is. The gradient or the slope basically represents the inclination. I'm going to write it right here, inclination. Basically, it is how slopey things are. So if you have a slope that's this way, this is how slopey it is. This is, you can actually just express it in degrees. This, you can say this is 45 degrees slope or 45 degree gradient. Or you can have something at least a lot less steep and say this is only 5 degree slope or 5 degree gradient. So basically it's the slopiness, or if you have a mountain, how steep something is. So you can also call it steepness. And so this is what we will be talking about, but specifically with coordinate geometry. So there's four different types of gradients, and all four of them are represented here. So first of all, there is positive and negative slope, and this right here, and basically the way to remember is what is positive, what is negative, is to have a little man go up the mountain from the left to the right. If the man is going up the mountain, or a woman that is, if he or she is going up the mountain, this is going to be a positive slope. This is a positive gradient. If he or she from left to right is going down the mountain, this is going to be a negative slope or a negative gradient. If he or she is basically just kind of standing there and not going anywhere, this is a zero gradient or zero slope. And finally, if he or she is barely standing here or is being impaled by this little thing, actually no, I don't want to impale anyone. Let's pretend he or she is barely balancing him or herself on this one thingy. This is an undefined gradient. So this is actually where we have no value. It's undefined. So this has no value. Now, so what are these and how do we find them? So there's positive, negative, zero, and undefined. And basically the way we find them is with this formula. And this is directly from your book. So basically the gradient m, or the slope m, of the line passing through points x1 and y1, x2 and y2 is defined as equals to y2 minus y1 divided by x2 minus x1. In other words, you can also express it as this. You can also basically say it equals to the y value, this whole I would call it delta y, or difference of y value, divided by the difference of x value. So basically this distance, and this would be, what is this, like 4 squares, divided by this distance here. And I believe this is like 2 squares. So in this case, since this is 4, and I think this is approximately 4, and this is approximately 2, and we know that this is a positive gradient, the value of this slope, let's call it m1 equals to 4 divided by 2, or 2, it equals to positive 2. So, and this is for question A. For question B, we know this is a negative slope because the man is going down. And what is our y value here? Well, it's approximately 2 as well, I think. I think this is about 2. It's not actually precise because I don't know what the squares are, but it's approximately 2 here. But this horizontal value is, I believe, 6. This is, I believe, 6. So for B, this was A. For B, we have a slightly different value here. It is going to be, and this will be 2 divided by negative 6. And it's negative because we know it's a negative slope. And so it's actually minus 1/3. So for B value, this is actually going to be minus 1/3. We know that any horizontal line will automatically give you gradient of 0. No matter what line you have, as long as it's horizontal, its slope is always 0. And we know that for D, it's undefined. And the reason it's undefined is because let's just say that this is a very, very little value, like this y, no, sorry, not x value. Let's start with y. Let's start with y and count how many squares this is. And it's approximately 4 squares. So it's actually 4 divided by, well, this part, and this part right here. And this part right here is actually 0. So it's 4 divided by 0. Now, if you do this on your calculator, you'll get an error. There's no divided by 0, and this is why it's undefined, because it doesn't exist. Or you can also basically say it gives you infinity value. And this is basically using these examples, but let's actually try actual points. I'm going to pick a question from the book that has an actual value for a point. And this is example from page 386, and basically here's what we need to do. Find the gradient of the line through -2, 1, and 2, 9. So we have 2 points. Let's mark them down right away. This is x1, y1, and it doesn't actually matter what order they're in. It will give you exactly the same value. So our formula is y2 minus y1, which is 9 minus 1, divided by x2 minus x1, which is 2 minus 2. In other words, it is 8 divided by 4, or it equals to 2. So this is our gradient. This is our slope for this line. And it's really that easy. Now, the second part right here, parallel and perpendicular lines, this is where it gets a little bit trickier. And when I say more difficult or more tricky, I actually really mean easier. I'm going to keep slope formula right here just so you can see it. And this is the next example. So here is our trapezoid. And we have line DC and line AB. And we do have a gradient for both of them. Now, when it comes to parallel lines, and this is the symbol for parallel lines, the parallel lines, this is a symbol, mean that you have exactly the same gradient, the same slope. So if the slope of these two lines is the same, it means that these two lines are parallel. In other words, then this is a trapezoid. Could be one of the possible questions. Can you tell us if this is a trapezoid? How do you tell? Well, you find the slope. What is the slope here? Well, it's y2 minus y1 divided by x2 minus x1. In other words, it's going to be 3/9. And here the slope is 1/3. And both of them are positive slopes. And both of them are equal because 3/9 is 1/3. In other words, CD is parallel to AB, and this is a trapezoid. So for when it comes to parallelity, if you have the same slope or same gradient, it means lines are parallel. Lines are parallel. And the other thing is perpendicularity. So this is basically when you want to find out if two lines are perpendicular. Let's put this example right here, and basically here's a little square, and we want to find out if it's actually a square and if this is actually 90 degrees. In other words, if these two lines AB and CB are perpendicular. So how do we find out if CB and AB are perpendicular? So is CB, this is sign for perpendicularity, perpendicular to AB. And here's how you find out if two lines are perpendicular. So you take the first gradient, M1, and in this case, you basically calculate it by dividing, we can actually do it on the side right here. Let's find gradient of CB. It's -2 divided by 3, or -2/3. This is our gradient number 1. And then you multiply this is a multiplication sign, multiply it by gradient of line 2. And in this case, gradient of AB is 3 divided by 2. And this is 3 seconds. This is M2. And their product, their multiplication product, has to be equal to -1 for these two lines to be perpendicular. So this will give you perpendicular lines. And this is something you may want to remember. So multiplying or cross-multiplying two gradients, two slopes of two lines, if it gives you -1, it means that these two lines are perpendicular. So in this case, let's cross-multiply 2/3 and -2/3 and 3 seconds. What will it give us? It will give us -6 divided by 6, or if you simplify this, it's going to be -1. In other words, this is a perpendicular, this is a 90-degree angle, these two lines are perpendicular, and this is definitely a square. So what you have to remember from this part is that same gradient for two lines means they're parallel, and if you get a product of two lines that equals to -1, these two lines are perpendicular. And essentially this is it for the gradient and parallel and perpendicular lines, and this is how you try to solve these problems. Anyway, thank you for watching, and good luck to you, and bye-bye.